Thank you for joining this lesson. We're going to study longitudes and latitudes, number 23 of this paper, whereby we are told that the position of towns A and B on the Earth's surface are 36 degrees north, 49 degrees in the east, and 36 degrees in the north, 131 degrees in the west, respectively. So this is town A, this one is town B. Find the difference in longitude between town A and town B. Therefore, we are having on the Earth's surface two towns. I can say the two towns are in supplementary longitudes, whereby one is just 49. This is a 49 degrees in the east. Then the other one is 131 degrees in the west. So in the far west, we have 131 degrees, but they are both on latitude 36 degrees in the north. Therefore, this being A, we shall have this one as B. So we say they are supplementary longitudes just because from 49 degrees in the east to 131 degrees in the west, we are getting an angle difference, or rather a longitude difference of 180. So because they are in opposite side of the prime meridian, then we are going to have 131 and 49 added. This will give us 180 degrees as the longitude difference between A and B, part B. Given that the radius of the Earth is 6370 kilometers, calculate the distance between town A and B along parallel latitude and B along a great circle. Therefore, along the parallel latitude, we will be calculating distance along latitude 36 degrees north, and this is distance along a small circle. In kilometers, the distance along a small circle is given by theta out of 360 2 pi r cosine of latitude. Theta in this case is the angle difference, or rather the longitude difference, which is already calculated at 180. Divide by 360 multiplied by 2 multiplied by pi, 22 out of 7, r 6370, cosine of 36, because they are in latitude 36. So we can compute this one using a calculator. 180 times 2 times 22 times 6370, cosine of 36, then we divide everything by 360 multiplied by 7. So this is going to give us 16,196.5 to 1 decimal place kilometers. Part 2, along a great circle. Distance between the two places along a great circle. So along a great circle now, from A to B, we will go through the North Pole, then down again to B. So from A through the North Pole and down to B, that is through a great circle. Now that it is along a great circle, we are supposed to know the angle difference now between the two places. This is a 0 degrees equator. Therefore, from 0 degrees equator to 36 degrees in the north, we have an angle difference of 36. And on the other side, to part B, we also have an angle difference of 36. So with angle differences of 36 and 36, and this is 0 degrees equator, a straight line, then we can get the angle at the center of the great circle, the arc AB, which has an angle theta at the center. And that angle theta is going to be, when we take 180 and we subtract 36 and 36, we're going to get 180. Therefore, we have an angle difference of 108, that is. Therefore, now, along a great circle, distance is usually given by theta out of 360 2 pi r. So we will have a theta of 108 out of 360 multiplied by 2 multiplied by pi multiplied by the radius of the Earth. This is 6370 kilometers. When we compute this, we shall have 108 multiplied by 2 multiplied by 22 multiplied by 3, 6370. Then we divide by 360 multiplied by 7. This will give us 12,012 kilometers. That is the distance now along the great circle. It should be noted that the distance along a great circle for two places on supplementary longitudes is the distance along the great circle, or rather the distance along the poles. Finally, we are given that another town C is 840 kilometers east of town B and on the same latitude as towns A and B. Find the longitude of town C. Therefore, now along the same latitude, we have a town C which is 840 kilometers east of B. So when we are at B, we move to the east a distance of 840. Now that we are moving along a small circle, then we can know the angle difference from 131 through a distance of 840. So the distance is known. This is equal to an angle difference which we don't know over 360 times 2 times pi times r 6370 cosine of latitude, which is 36 as already indicated. So to get the theta angle difference, we shall have 840 multiplied by 360 multiplied by 7. Then we divide everything by 22 by 2 by 6370 cosine of 36, and this is going to give us 9.335 degrees. So we have an angle difference of 9.335 degrees, and we are moving from a longitude which is already 131. So when we move towards the east, this is west, remember, towards the eastern angle difference of 9, we will find ourselves at, when we take 131 and we subtract, we're going to find ourselves at 121.665 degrees, still in the west, because we have an angle difference of 9, which means the angle now, or the latitude, the longitude of C, the longitude of C is going to be 121.665 degrees west. It's very important. If we had been told to indicate the coordinates of C, then C could have been, we start with the latitude, then the longitude, but it is not our concern according to this examiner.